The air is thin, and biting cold here. 4,000 meters above sea level, on the Tibetan plateau. It is quiet. A primeval silence, that hangs over the glaciers, of the Tangula Mountains. Here, the water begins as a trickle. Innocent and clear. Unaware that it is the lifeblood, of nearly 60 million people downstream. This is the birth of the Mekong. Known here as the Za Chu, and soon to become the Lansang. But today, the silence is a lie. Because today, a signal is traveling, through the fiber optic cables, buried deep within the bedrock of the gorge. It is a digital command. Synchronized to the millisecond. Routed to the control centers, of over a dozen megadams, cascading down the river's spine. From the towering walls, of the upper Mekong in China. Through the rugged hills of Laos. Down to the flat expanse of Cambodia. The operators hesitate. Hands hovering over the manual overrides. But the scenario demands execution. The command is locked in. Total discharge. In the control room, of the Nuozadu Dam. One of the largest reservoirs on the cascade. The alarms begin to scream. This is not a drill. This is the theoretical limit, of hydraulic engineering. The massive steel floodgates. Thick barriers, designed to hold back the weight of mountains. Begin to groan. Hydraulic pistons, pressurized to hundreds of bars, engage with a deep, earth-shaking thrum. Slowly. Agonizingly. The gates rise. For a split second, there is a vacuum. A gap between the bottom of the gate, and the concrete sill. And then, gravity takes the wheel. The water, compressed under enormous hydrostatic pressure, at the base of the dam, does not flow. It detonates. It shoots out in a horizontal jet. White and furious. Moving at speeds exceeding 100 kilometers per hour. The sound is not a splash. It is a continuous, deafening roar. Like the blast of a rocket engine, that never ends. Mist instantly vaporizes into a dense fog. Rising hundreds of meters into the air. This is the beginning of the pulse. A hydraulic hammer, weighing billions of metric tons. Swinging down, from the roof of the world. To understand the violence of what is happening, we must look at the physics, of the Lansang Cascade. The river here drops significantly in elevation, over a short distance. This is potential energy. Mass times gravity times height. By storing water in reservoirs, we accumulate this potential energy. When the gates open simultaneously, that stored energy is converted instantly, into kinetic energy. It is no longer static. It is a weapon. The water exiting the Nuozadu, and Shaowan dams, is not just liquid. It is a dense slurry of turbulence. As the floodgates fully retract, the reservoirs begin to empty. We are talking about tens of billions, of cubic meters of water. To visualize this, imagine a cube of water 1 kilometer long, 1 kilometer wide, and 1 kilometer high. Now multiply that by 20 or 30. That is the volume, now charging down the narrow gorges of Yunnan. The river channel here, is constrained by steep canyon walls. In fluid dynamics, when you force a massive volume of fluid, through a narrow pipe, the velocity increases. This is the Venturi effect, on a planetary scale. The water cannot spread out, so it stacks up. The river level doesn't just rise. It surges vertically. A wall of water. 10, perhaps 20 meters higher than the normal flow. Begins to tear down the canyon. Trees that have clung to the riverbanks for decades, are snapped like matchsticks. Their roots ripped from the granite. Boulders the size of cars, are lifted into the suspension. Becoming projectiles within the flow. The friction between the water, and the canyon walls, generates heat. Though not enough to boil the water, enough to alter the local microclimate of the gorge. As this initial pulse races south, it encounters the next dam in the cascade. In a normal flood scenario, this dam would act as a break. But today, its gates are also wide open. The incoming surge, meets the outgoing discharge. The turbulence at the confluence of these flows, creates standing waves. hydraulic jumps that rise 30 meters into the air. The concrete spillways vibrate at frequencies that threaten their structural integrity. The water is moving so fast that it begins to cavitate. Tiny bubbles of low pressure form and collapse against the concrete surfaces, blasting away microscopic pits of material. If this continues, the spillways themselves will be eaten alive by the water. Most turn away. But here at Surphysia, we decode the math behind the chaos. Support the mission by subscribing now. The surge crosses the border. It leaves the steep canyons of China and enters the Golden Triangle, where the borders of Thailand, Laos, and Myanmar meet. Here, the river widens. But the velocity is still lethal. The physics changes now. The channel is less constrained, so the water begins to spread. The Xayaburi Dam in Laos is the next major checkpoint. It is a run-of-the-river dam, designed to let water flow through. But it still holds a significant head of water. As the pulse arrives from the north, it slams into the back of the reservoir. The water level rises with terrifying speed. The operators at Xayaburi have already opened their gates, contributing their own volume to the disaster. But the incoming wave from the north acts like a piston. It shoves the water through the turbines and spillways with such force that the river below turns into a frothing cauldron of whitewater. Villages along the banks in Chiang Saen, Thailand, usually watch the river rise and fall in a gentle seasonal rhythm. Today, they hear it before they see it. A low-frequency rumble, vibrating through the ground. The river, usually a muddy brown, turns a chaotic, churning white. The gauge measures the rise not in centimeters per hour, but in meters per minute. The embankments are overtopped instantly. The water doesn't flood. It invades. It carries with it the debris of the upper gorges, shattered timber, plastic waste, and the sediment of 1,000 kilometers of erosion. We must talk about the sediment. This is the hidden killer. The Mekong is a muddy river, carrying millions of tons of nutrient-rich silt. Usually, the dams trap this sediment, starving the downstream delta. But with the floodgates fully open, and the reservoirs draining, the sediment that has accumulated for years, behind the dam walls, is mobilized. This is a sediment flush, of apocalyptic proportions. The water becomes thicker, heavier. Its density increases, which means its kinetic energy increases. A cubic meter of clear water weighs 1,000 kilograms. A cubic meter of this hyperconcentrated sludge can weigh 1,200 kilograms or more. It strikes obstacles with 20% more force. As the deluge pushes further south, into the heart of Laos, and along the Thai border, the devastation widens. The capital, Vientiane, faces a river that has swollen to 3 times its width. The promenade, usually filled with tourists and night markets, is gone, buried under 4 meters of turbulent brown water. The sandbags placed by emergency crews are laughable. They are washed away in seconds. The hydrodynamics here are complex. The river is trying to find equilibrium, but the volume is too high. It begins to cut new channels. It scours the agricultural lands, stripping away the topsoil that took centuries to form. This is known as shear stress. The water drags against the bottom of the riverbed with such force that it alters the geography of the map. Islands in the river are eroded and disappear overnight. Further south, the pulse reaches the Cone Falls on the Laos-Cambodia border. This is the widest waterfall in the world. Usually, it is a magnificent, braided network of channels. Now, it is a single, terrifying sheet of water. The noise is loud enough to rupture eardrums. The mist rising from the falls creates a permanent storm cloud, raining down on the surrounding jungle. The sheer volume of water smooths out the falls. The rocks are drowned. It is just a massive, sloping ramp of liquid destruction. Now, the water enters Cambodia. And here, physics plays a cruel trick. The terrain flattens out completely. The energy that was directed forward, now pushes outward. The floodplains of Krati and Kampong Cham are submerged. But the true anomaly awaits at Phnom Penh. The confluence of the Mekong and the Tunnel Sap River. Normally, the Tunnel Sap is a unique hydrological lung. In the rainy season, the Mekong rises so high that it forces the Tunnel Sap River to reverse direction, flowing backward into the Great Tunnel Sap Lake. It acts as a natural buffer. But this is not a normal season. This is a sudden, violent injection. The pulse hits the confluence with the force of a tidal wave. The reversal of the tunnel sap is instantaneous and violent. The water surges up the tributary towards the lake at speeds never before recorded. It creates a bore, a solitary wave traveling upstream, that smashes into the floating villages on the lake. The lake itself, usually expanding slowly over months, is force-fed billions of cubic meters of water in a matter of days. The ecosystem cannot adapt. Fish, confused by the sudden pressure changes and the turbidity of the water, die in the millions. The oxygen levels in the water plummet as organic matter is churned up and decomposed. It is a hypoxic event on a massive scale. Finally, the water reaches the end of the line. The Mekong Delta in Vietnam. This is the rice bowl of the region. A flat, intricate web of canals and paddy fields that sits barely meters above sea level. The delta is already fighting a war on two fronts: sinking land and rising seas. When the pulse arrives, it meets the tides of the South China Sea. If the tide is low, the water may escape, though it will scour the channels deep. But if the pulse coincides with a high tide, the result is catastrophic. The freshwater wall meets the saltwater wall. The river has nowhere to go. It piles up. The dikes and levees, protecting the rice paddies, are designed for seasonal floods, for a gradual rise. They are not designed for this. They fail in a chain reaction. The water bursts through, inundating the fields with depths of 3 to 4 meters. But it is not just the depth. It is the duration. With the dams still open, the water keeps coming. The infrastructure of the delta, bridges, roads, power lines, begins to crumble. The soil, already waterlogged, liquefies. Foundations lose their grip. Houses slide into the widening canals. The fresh water flushes out the saltwater intrusion temporarily, which sounds beneficial. But the violence of the flow destroys the intricate irrigation systems that manage salinity. And then, there is the sediment plume. As the water finally exits into the ocean, it carries the land with it. Satellite imagery would show a massive, brown stain, spreading hundreds of kilometers into the blue ocean. This is the soil of Tibet, of Yunnan, of Laos, lost forever to the abyss. When the reservoirs are finally empty, or the gates are closed, the silence returns. But it is a different silence. It is the silence of a landscape scoured clean. The river channels are deeper. The banks are wider. And the human footprint along the river has been erased. The potential energy has been spent. The math has resolved itself. The universe is full of chaos, but we are here to decode it. Stay connected to Surphysia.